Thanks so much for joining us today. I cannot believe that it is the end of April already, but here we are on our fourth month of 2016 doing another webinar. So today we're going to be talking about the value of a solid leak detection program. David Barlow with TE Connectivity is going to join us and kind of share sort of more of a case study, kind of their journey as they've implemented their compressed air survey program at their facility and the great results they've had and the impact it's had on the things they've been able to do with other programs within their condition-based monitoring and things like that. So should be a really good session, and glad you guys have been able to join us. Before we get started, since obviously compressed air is of interest to those of you that are in our audience today, I did just want to make you guys aware of two different things that we've got that are pretty new to UE Systems. We just launched about a month ago our compressed air survey online course. So for those of you that maybe have taken in the past our in-person one-day compressed air class that we had, or had seen it on the calendar and it just never came to an area near you, what we've done is we've taken that class and we've condensed it into 6 online modules that you can take kind of whenever, wherever, on your schedule, at your pace. Do one module at a time, do all of it at one sitting, whatever suits your needs. But we're pretty excited about it. It's pretty cool, very interactive. It keeps you engaged. Has kind of quiz questions throughout it, different interactive things that you need to do. So we're pretty excited about it. You can check that out on our website, and we'll probably send some follow-up information to you guys as well, just reminding you about it. But for any of you guys that are interested or have questions, just let us know. And then, of course, if you have taken it or are going to take it, we'd obviously love to get some feedback since it is pretty brand new. So just wanted to point that out before this thing was over and we might have run out of time. The other thing, just to make you all aware of, is we just launched our leak survey app. Right now we have it available for iPhones and iPads. The Android version is coming out probably in the next month or so. So for those of you that don't use Apple products, that's not too far behind, but we had to start somewhere. So what's going to be really cool about that is it's going to let you create a compressed air leak survey report, obviously like literally in the palm of your hand while you're actually out there running your routes. You're going to enter your data right there into your phone or on your iPad, and right from there you're going to be able to generate a report that you email to yourself or to your boss or to whomever needs to have it. And it's really going to just make it really nice, kind of easy tool to use. So we're pretty excited about that. You just go to the App Store and you can type in leak survey or type in UE Systems and you can find it. It's free. So take a look at that if that's something you guys are out there doing. And again, let us know what you think, because obviously everything is always in need of continuous improvement, and we'll definitely take that feedback and put it to good use. So pretty excited about those two things. So I just wanted to give those a little bit of airtime before I turn things over to David. So before I do that, just a couple housekeeping items. I am recording this, so if you have to pop off or you've got a colleague that couldn't attend, we'll have this recording up on our website in the training section in the on-demand education part of our site, probably by the end of the day tomorrow. So you can check that out there. We invite you to ask questions as we're going through the presentation. You can just type those into the little box on the right-hand side. I'll be monitoring those, and I'll get those tossed over to David throughout the presentation if it makes sense to chime in and interrupt him if it's something pretty pertinent to what he's talking about, or of course we'll have some time for those at the end as well. So bear with us. We are doing this live, so I just always like to throw out the caveat: if we have any technical issues, sound or any internet issues, we'll get those fixed as quickly as we can. So just bear with us. But we love that we kind of get to feel a little connected to folks, even though we're all separated out throughout the country, and we even have some international folks on. So that part makes it worth the little bit of heartburn that those technical difficulties might give us. So with that, I will stop rambling, and I am going to turn the screen over to David and let him take it away.
Thanks, Maureen. Is everything working okay?
Yep, I see your screen. Everything looks great. Thank you.
Okay. Good afternoon, everyone. My name is David Barlow, facilities manager here at Greensboro, North Carolina. I'll start out with saying I was raised in the mountains of North Carolina, so if there's some southern terms or slang you don't understand, feel free to stop me and ask questions. So here at TE Connectivity in Greensboro, we have two facilities about 4 miles apart. We are a primary automotive tier 2 supplier. We make millions and millions and millions of plastic connectors, so any type of connection that goes in just about any type of vehicle, we probably have it or offer it. So that's a little bit about what we do. Maureen, I'm having a little difficult getting my slideshow to advance.
Okay, you might sometimes if you just click on the middle of the screen, that kind of gets it realizing you're trying to.
Okay, there it goes.
There you go.
Okay, I think we're back on now. So there again, like I say, we have starting to make a lot of parts for electric vehicles. We make parts for the infotainment, wires and tubes, relays, terminals, connectors, cable assemblies, some of the anti-brake modules, and then we have quite a bit of new sensor technology that's coming online also. We started our journey about 3 years ago. It was primarily to try to gain some cost advantage in reducing our cost of compressed air. As we got into it, we did realize that not only did we improve the cost, we improved the quality of the product, and we improved the safety of our facility while we were doing this. Some of the original objectives we had when we started this process was basically to identify and repair air leaks. We also wanted to lower the plant air pressure from 110 psi to 85 psi, try to gain some savings from not running as much pressure. In one of our compressor rooms, of which we have 3, we wanted to actually see if we could get one compressor to turn completely off and lower our demand. We had some indication that when we started, we were wasting about 50% of our air. So with 2 compressors running, we had a goal of seeing if we could cut one of those compressors off. As we got into the project, we learned that there were several other things we needed to improve along the way. We wanted to provide a better lockout, tagout device at each of the molding presses. We wanted to provide emergency air dump for all of our compressed air in the molding cell. We wanted to provide filter and regulated air for all equipment. Reduce opportunities for air leaks, not only reduce the air leaks, but reduce the opportunities for those also. And we wanted to reduce the airflow restrictions to improve the flow of air when we started turning the pressure down. Like I said, we started about March of 2013. Just to kind of give you a little bit about our facility. We've got 2 facilities. One's about 200,000 square foot. The other's about 125,000 square foot. The bigger facility is called Peg Road. We have 2 compressor rooms with 6 compressors total. Each compressor room is set up with a primary compressor, a trimming compressor, and a backup compressor. So between the 3 compressor rooms, we are spending about $400,000 annually for compressed air or electricity to run those compressors. At any given time, we're running about 800 horsepower. I know that's not extremely large, but it's not extremely small either, based on some other people we've worked with. So it's a pretty good amount of horsepower that we're running full time. We've got about 550 horsepower that we run somewhere between 50 and 80% of the time, and then we've got about 800 horsepower of backup capacity. And there at the bottom of that matrix, I just put in an energy usage. The PEG 1 compressor room, when we started this project about 3 years ago, the annual energy usage was over $150,000 a year. We're down under 100, and it's trending right around 90,000 a year right now. The second room at PEG, it runs about $125,000 electricity a year. We haven't done a lot of work in that area, but we have seen some reduction. And then the Burgess facility, it runs about $200,000 per year. And we've seen some reduction in that. We don't have any type of monitoring system on that to know exactly how much that's reduced. So it's kind of an estimate. So when we started this process, quickly learned that it was going to be a whole lot more involved than what we thought. This war on air leak slide kind of became about probably 6 or 8 months after we got into the process. But our sales rep, Adrian Master, he came in, helped us select what kind of equipment we needed, what kind of training we needed. That's a very important piece of it. We came up with an air leak diagnostic and repair cart. So while we were out wandering the 200,000 square foot of floor, we had everything we needed at kind of point of use, ready to make those repairs. We also did a lot of work for improving the sustainability of it. So while we were out there fixing air leaks, we tried to pay attention to how can we reduce the number of fittings, how can we improve the fittings. And we saw a lot of Teflon tape being used, which is against our preference. We like to use the pipe dope. It doesn't break loose and get in the valves and things and clog it up. So there's just a lot of opportunity there to improve the sustainability of it. One of the biggest things that we implemented was, in the past we had a corporate facilities guy come in like once a year and do an air leak survey for us and tag everything. And it might be 3 or 4 months before we got around to actually trying to find them again and fix them. So one of the biggest things we really did was we implemented basically a find and fix mentality. So anytime we found an air leak, if at all possible, we try to lock everything out, fix it, and get everything back up and running within just a short period of time. And we tried to be as systematic and data-driven as possible with the amount of information that we did have. So that was kind of our 5-pronged approach that came about several months after we got into it. Like I say, one of the very first things we did, Adrian came in and helped us determine what kind of equipment we needed. We actually ended up buying kind of the Cadillac version, the Ultraprobe 15,000. We bought that in December of 2012. We sent David Willis, one of our technicians, to certification. I'll go ahead and put a plug in for UE. That certification is very well worth the time and the money. We don't have a lot of things that they go over in class, such as steam traps, but I think they come out of that class very well rounded and have a really good understanding of the technology and how it works. Later on, our condition-based monitoring technician, James Austin, he completed the Level 1 certification in March of 2014. We have another guy over at the other facility, Tom Burnett. He's an assembly technician. He kind of picked up a lot of this during our Kaizen events that we were running, and is also a very good ultrasound technician for us, and kind of takes the lead in that particular department. Since that first gun that we bought, the 15,000, we have added 2 of the Ultraprobe 3000s. These guns are a lot smaller, a lot easier to kind of pick up and go, and just kind of a point and shoot type approach. So I personally think those are a little bit easier to use. We basically take the scan, read the decimal, we jot it down on the form, and then we key it into the spreadsheet later on to calculate the savings. One of the first air leak reduction Kaizen events we had was in the molding department. When we started going out there, we found all kinds of leaks, and as you can see from the picture there, we had all kinds of opportunities. But this is all the stuff we actually removed from the press, and we did most of this kind of intermittently while the press was running. So at the end of the 3 or 4 days, this is all the stuff that we actually pulled off of the press. So you can see the amount of opportunities that we removed that could potentially create a leak further down the road. This is when we really kind of started thinking about how we replumb things and how we go forward with our sustainability side of it. We did kind of a quick calculation one time, and I think between the 2 buildings, we figured we had over 300,000 air leak connections. So, you know, it's a never-ending battle trying to maintain a good, solid air leak program. Some of the other things we did from that same Kaizen event, basically when we took all that stuff off, we replumbed it. We tried to minimize the number of feet of hose. If we only needed 3 foot, we put 3 foot back in. We didn't coil it up and have the opportunity for it to get nicked or burned. So we basically started communicating about the Teflon tape, making sure that we didn't use it. We used a loctite pipe dope. We also started looking at the air prep units, making sure the filters got changed and the bowls got cleaned. So there's just a whole lot of things we did to kind of improve our air prep system. That picture basically shows a situation that the one on the left that showed 18 connections after we basically went to 6 connections and 8 foot of hose. Before we had about 24 foot of hose. So you can kind of see the before and after and how much simpler it is and how much easier it is now to maintain those air leaks on that one particular operation. Just kind of as a FYI, in our molding department, we have 120 of these injection molding machines. Each molding machine has a robot or a picker and about 5 or 6 other pieces of auxiliary equipment, grinders, blenders, thermolators, metal detectors. So each one of those using some type of compressed air. So it really is kind of a jungle out there with 120 presses and trying to maintain the air on all of these pieces of equipment. One of the things we also learned from that Kaizen event, we bought some CFM digital flow meters and put in strategic places, and we had little data loggers with them. One of the things we wanted to learn was basically where our compressed air was used and to see if it kind of applied the old 80-20 rule. We found out that 85% of our air was used by 33% of the equipment. So it kind of gave us a little better idea about how to focus our efforts and what we need to pay attention to. Also in the primary compressor room in PEG 1, we have this relatively new system from Ingersoll Rand. It's called IntelliFlow. It has a really nice dashboard that shows us how many of the compressors are running, at what level they're running with our variable speed. That number in the upper right-hand corner there, 5.9 CFM per kilowatt hour. There's actually some literature out there that says if you can produce somewhere in the neighborhood of 6 CFM per kilowatt hour, that's kind of considered world class. So not only from an air leak standpoint, where we're reducing our usage, we tried to improve the efficiency of how we actually compress the air too. So we installed like a 3,000 gallon tank. That gives us time enough to drop a compressor out, bring another one on without seeing any degradation in our air pressure across our main manifold. So that system actually gave us the visibility to see what we were doing from an air leak standpoint and what kind of impact. I apologize for that. One of the devices I forgot to turn off. Another thing we did when we started this, James had his toolbox and David Willis had his toolbox and I had a handful of tools. So we bought an air leak diagnostics cart. We kind of upfitted it with some spare parts. We put our UE ultrasound equipment in it. We've got a bunch of hand tools in it. We've got a drop cord on it. We've got a CFM meter on board where we can plug in and see what kind of airflow that we're getting in devices. So this cart's actually saved us several thousand miles of travel. On a given day, one of our guys probably walks 4 or 5 miles just back and forth to the tool crib getting parts. So this cart made us a lot more productive. It made us a lot easier to basically ask an operator to shut a press down for 2 or 3 minutes and all. We could get in and get out really quick. So I would highly recommend that if you're starting this process to dedicate a cart and some tools and some spare parts and keeping everything kind of together in 5S. We have a really strong lean program here. and we all try to do a good job of 5Sing. This part doesn't look always this clean, but we try to keep it clean and organized and everything in its place. One of the things we also developed from a kind of an air leak process standard work was a form. So we kind of came up with a few steps that air leak technician, once they identify the air leak with the ultrasound meter, they record the information in the air leak log that we keep on the cart. Basically has a tag number of what department they were in, the equipment description, the leak description, the number of decibels that comes off the ultrasound gun, whether we fixed it or not, and whether we needed a work order or not. So, say if the leak was, our mission was basically to find the leak and fix it immediately. If it wasn't, we weren't able to fix it because we didn't have a part or we couldn't get the downtime for whatever reason, we implemented a three-part tag system. So once we identified the leak, we hung this tag on it. We were going to create a work order for that leak. We filled the three-part tag out with the information that was required. We attached the red part of the tag to an air leak board in the maintenance shop, and then we left the green and the yellow sections as close to the leak as possible. Have to kind of pay attention to what kind of equipment you've got and where you can hang these tags. Sometimes they get in the way of cylinders, so have to be real careful about where and sometimes how you hang these tags in the equipment. But after a few lessons learned, you'll typically pick up on where not to put them. This is the air leak board that we generated for the maintenance department. We have like 5 rows of presses. Each row has 25 to 30 presses. So each row has a rack for A1, A2, A3. So anytime we found a leak, we put the red tag on that board. That would give us a visual to someone on another ship that there's a leak on that press. So in an ideal world, if you had a work order to go out, work on like A22, you could look at the board, see if there was a leak on it, and try to make that repair during that other work order. So we used that for a little while. In all honesty, we've kind of gotten away from it because our leaks are a whole lot less and a whole lot easier to manage now. And like I say, we still try to fix probably 80 or 90% of leaks as soon as we find them. One of the things we did notice, we've got all kinds of technicians and engineers and plumbers in the facility, and everybody does things a little bit different. So we came up with I think it was about a 25 or 30 page compressed air plumbing guideline. We did some classroom training on it. Everybody that was supposed to be involved in some type of compressed air plumbing installation, we tried to get this word out to try to help reduce the variation in the plumbing practices. One of the things we see is, continue to see, is kind of interchanging metric and standard fittings together. We've got a whole lot of equipment that uses both of those. We're probably half and half. We've got a lot of metric tubing. We've got a lot of standard tubing. So if you don't pay attention to those, even though it kind of feels like it snugs up pretty good, it will leak. So James continuously to find air leaks that are ultimately the fault of having metric and standard fittings components put together. The air prep system on this molding rack, we had on the left there basically air coming in, a gauge, and a manifold with some quick disconnects. We weren't filtering it. We didn't have a way to really dump the air from emergency lockout, tagout standpoint. So one of the things we did to improve that, when we brought the air down, we actually ran it through a drip lag so we could catch some of the contaminants before they got into the air prep equipment. The first piece of air, we had a lockout, tagout unit, a filter regulator, had some diagnostic ports where we could actually hook the airflow or air leak card up to try to understand how much air that particular press is using. Our safety group decided we needed to go to these Cat 4E dumps. That's actually a festive valve on that particular unit. And then it fed a manifold in the bottom that allowed us to have 8 quick disconnects and 2 secondary regulators, which would allow us to turn the air pressure down to some smaller stuff to 35 or 45 rather than using the 85 or 90 psi that's on the plant system. So that was a big improvement for us. Like I say, we've got like 120 of these racks. We're probably maybe 25% through going through the department making all these retrofits. So it takes a lot of time and money to make this upgrade, but we're starting to see it pay off. Some of the other physical changes to the racks, basically before it's kind of complicated and restrictive. The manifold is not easy to label and easy to figure out once you go up to it. With the new manifold system, we try to label everything. We try to put gauges on it so we can do a little bit better job with our autonomous maintenance, and it aids the person doing the breakdown to figure out a little bit better about where the problem's at. We've got this big Motan system that moves plastic resin from about 30 Gaylords out to 120 molding presses. It's a vacuum system, so we vacuum the material resins out of these Gaylords and blow it out or vacuum it out to the molding presses. Each one of those Gaylords is setting on a tilter, so as the material goes down during the shift, the tilter, an operator raises the tilter up. That raising motion is done by a pneumatic bladder. So each one of these tilters had a little regulator on it, had a little cutoff valve on it. We found over 30 leaks and about $3,400 worth of leaks when we went through and redid that. So one of the things from a sustainment standpoint was we didn't really want a guy to have to spend all that time going through and scanning that each time. The air drops are in the center of 2 rows of those, so it's kind of hard and dangerous to crawl over to get back there too. So we basically replumbed it. We put it all on one main feed. We installed a primary filter regulator so we could keep the air clean. We pulled off all these individual regulators that had a lot of potential for leak and get damaged with forklifts and stuff. We installed a valve at each tilter so we could cut it off if we did need to make a repair. Then we installed a CFM meter to tell us how much air we're using in that area. We actually had to put the filter and regulator kind of up in the ceiling of the mezzanine, which is about 10 feet off the ground. Makes it a little bit difficult to get to work on, but from a meter standpoint, we took that picture just a couple of days ago. There on the right where it says 0.4, I can go by there and look at that meter and tell for all 30 Gaylords that we're only using 0.4 CFMs of compressed air. So without having to get the ultrasound gun out, or without having to really do much at all, we can walk by there and look at that meter and tell about how many leaks we have in that system. Once the Gaylord is tilted and it goes up, the bladder stays full and everything's tight. It doesn't really use any air unless you're raising the tilter. So it's a real simple system, really kind of complicated from an air leak management standpoint, but with this flow meter on there, it makes it real easy to go by and check to make sure we're in pretty good shape. So once that meter gets up to 1 or 2 CFM, we'll take the ultrasound gun back there and see if we can hunt it down and try to fix it. But it's a big time saver for us. It basically reduced about a 1 hour PM down to about a minute. Another big thing we tried to do throughout the facility was increase the compressed air cost awareness. So this is one of the slideshows we put up on the bulletin board. We put it up on some of our TVs. I think we've probably got 15 or 20 TVs throughout the facilities. So one of the things when we started talking about, we have a lot of these blow-off nozzles, and a lot of the operators clean off their machines at the end of the shift with compressed air. The 1/4-inch blow-off nozzle uses about the same amount of electricity as 500-watt bulbs. So that was kind of an eye-opening for all of us. Like I say, it does make people a little bit aware about how expensive compressed air is. in general, I think the thought is that compressed air is free and we can blow it and use it as we see fit, but it's actually the most expensive utility that any manufacturing facility will use. Another picture we put up is to try to give some kind of indication. If you've got a 16-inch tube or orifice that's blowing air 24/7, you're wasting about $732 a year. If you bump that up to a quarter-inch diameter tube, you're up in the $11,000–$12,000 worth of compressed air. There again, like I said, compressed air is the most expensive utility that we use every day to run a business. One of the things that most people don't know that I've recently learned is for the amount of energy that you put into a compressor to compress air, about 70 to 80% of that energy leaves the compressor as heat. So when you go into a compressor room, there's usually a lot of airflow. They're usually fairly warm, especially during the summer. But that's where most of that energy goes, is into generating heat when you're making that compression. So just right off the bat, without any leaks, you know, compressed air is already like 4 times more expensive than electricity because of that loss of heat during the compressing process. We did find out once we kind of started lowering the air pressure from 110 that we have some valgated molds that require pressure in the 100 to 110 psi. So we got with our one of our pneumatics reps. We installed these little air boosters on there with an accumulator tank, and it can these particular
Oh, David?
boosters can double the
There you
pressure
go.
of what you put in. So if you put in 75, you get in. So they do waste a little bit of air, but at the same time, for an application where we needed 100, 110 psi, I think we have about 10 or 12 of these in the facility now, and actually able to give the process a better pressure and a more reliable process since we put these in. Another awareness thing we found out was we use a lot of these vacuum venturis to transport plastic resin from machine to machine. They hook up a little quarter-inch air line. They actually are very inexpensive. We typically don't put any kind of cutoff on them or try to manage them with a solenoid valve, so they run 24/7. And the annual cost of electricity to generate the air to operate those are over $2,000. We went back and looked at some of the other processes where we were using these little 3/4 horse blower motors. The annual cost of electricity to run those blower motors 24/7 is about $500. So we had over 12 or 15 of these vacuum venturis throughout the facility, and we've eliminated most of them. I think we still may have 1 or 2 around, but we kind of have to keep an eye on them, make sure some of the engineers don't sneak them back in. But it was a tremendous saving by just going to these, you know, little blower motors rather than using those vacuum venturis. Just to provide you a little bit of data, in our primary compressor room that we have the IntelliFlow system. Back in 2013, I pulled off some data, did a screenshot of it. Like I said, we've got a 200 horse that runs full-time 24/7, and we trim with a 200 horse Nirvana Ingersoll Rand rotary screw compressor. At this particular time, that compressor was running about 80 or 90% of the time. You can see it pretty much peaked out all during the week. I think there at the beginning and the end of that graph was over a weekend period that our volumes did go down a little bit. And then just the other night, I took a screenshot of this picture of where we currently are. And we're down around, we're under 20% now of that Nirvana running. So we're almost able to get to the point where we can cut our trimming compressor off. So basically that's, you know, 80% of 200 horsepower that we've been able to eliminate from a usage standpoint. It also, in our savings, we don't try to capture, you know, less wear on the compressors, which gives them longer life or less maintenance required. But that's a tremendous cost savings, too, that we haven't tried to dollarize yet. I just, so real quick, I haven't gone back and updated our savings for this year so far, but when we started in 2013, like I say, we got about 10 months of that year. We were learning a little bit about how to use the equipment and how to develop in the process, but we still able to quantify over $88,000 in savings. 2014 was kind of a bumper crop year for us. We saved over $200,000. We had a couple technicians and some kinds of events that really gave us a boost in resources for that effort. And at that point, 2014 was the first time our accountants started noticing the power bill going down. So once we got a little bit of recognition and proof that all this effort was actually saving us money, we got some pretty good recognition for that. So that's one of the things that actually led us into able to dedicate a couple full-time condition-based monitoring technicians, which one of their duties is air leak savings. So that was really beneficial to try to help document those savings and make sure you publish them and make sure your management is aware of the efforts that you're doing. It helps you get resources. The UE spreadsheet that comes with the guns, if any of you have used them, it's really easy to use. You basically punch in what state you're at, what the decimals are, what the air pressure is, gives you a little place to put the leak descriptions in, so it calculates all that for you. And when we first started doing this, some of the folks didn't really believe it, but with the IntelliFlow system that we have on our compressors back in the one room, I can vouch for UE that their spreadsheet is within 10% of what our actual usage is when we add all this stuff up. So I know basically how much electricity I spend to generate so many horsepower of CFM, and I know about how many CFMs come through different orifices, so I know about what the dollar amount is. And the numbers from the IntelliFlow system and the UE system typically tie off back pretty close. So it is a very good spreadsheet, and it's been one of the biggest things to kind of help us get resources and quantify our savings that we can actually defend. Like I say, a couple of other accomplishments. Right now we have reduced our air pressure from 110 down to 90. We did get down to 85 for a couple of weeks. We had some processes starting to fuss a little bit, so that's when we started adding the boosters, and we're about to the point where we're going to try lowering it again after we've got some of these, a couple more of these boosters in. Like I say, we ran a lot of TPM kinds of events where we used the ultrasound and air leak savings, and I think we probably had over 20 of those events that saved over $100,000. That was included mainly in that $200,000. Like I say, Greensboro campus, as I mentioned before, we have over 250, 300,000 compressed air connections. So it's just a constant battle to try to stay on top of that. Let's say also air leaks have a big impact on safety, quality, and equipment reliability. And from a quality standpoint, if you've got a cylinder that's got a bad seal in and it's leaking, at some point it's not going to make the complete stroke. So it's going to drop the product. It's going to create a quality issue. So these air leaks, like I say, do have a big impact on the quality and safety. From a safety standpoint, all the interlocks we put in place, all the lockout, tagout valves, all the Cat 4 valves that we're putting in place and making the facility a whole lot safer also. So just to kind of summarize, I can't stress enough how important it is to have dedicated, trained, accountable resources. So if anybody's looking to buy an ultrasound gun, if you buy it and want to put it on the shelf, you might want to just go ahead and save your money. So I would recommend identifying one of your technicians that's going to be accountable for probably on the road type situation with that air leaks. So before you buy the gun, you need to have a resource that is allowed to spend time on this. It will take a little bit of time to learn the process and to learn your operations, but there again, this sending them to the UE training or some type of certification is highly recommended. Both of our technicians are very confident with the gun and are very familiar and know how to train other people with it. Like I say, having a well-defined process, instead of just going out there randomly, kind of taking readings and fixing stuff and not documenting it. Having a process to document and tracking it will help you sell the process, help you sell the program so you can get more guns and more people to move you further down the path of success. Like I say, the ultrasound equipment and the training, very, very important. So it really takes all three of those. It takes the equipment and the training and the resources and the process before you really kind of get into that sweet spot and start seeing a lot of productivity and benefits for the company. That's pretty much it. I do have a couple thank yous I'd like to throw out there. Adrian Messer, he was one of our UE sales reps at the time that instead of just selling us a gun and then giving us a call a month or two later, he came in and made sure we all had a good basic understanding of it. He helped us understand how important it was to get someone certified on how to use it. One of the biggest things that we didn't understand at the time was he basically told us, go out and find all the 70, 80 decibel air leaks first, fix those, and then you can hear the smaller ones. But we didn't really understand that, so when we went out and started, although we could hear the big ones, we were also trying to find and fix all the 10 and 15 decibel ones, and that's really, really hard to do. Until you get rid of the big air leaks, it's hard to find those smaller ones. So the noise bounces around so much in most facilities that that little bit of advice, we didn't really understand it until we actually kind of got our feet wet and knew what he was talking about. James Austin, he's currently our TE condition-based monitoring technician. He's picked up the process very quickly, has a very strong interest in reducing air leaks, and I've heard him fuss at more than one employee for wasting his compressed air, so shout out to him for all those efforts. David Willis is our maintenance technician over at Burgess. He's really the first employee that we picked to kind of learn and send to ultrasound training. He was very instrumental in helping us develop this process. So I appreciate all the efforts there, and like I say, James and Davis are continually helping with the process and helping us move forward. Just a couple of thoughts. One of the sayings I've tried to come up with when I talk to our management and our accountants is, they kind of think air leaks, once you fix them, they're done. But air leaks are a whole lot like mowing the grass. There's never an end. So it's just a constant battle. We can actually go 2 or 3 months without doing much air leak work, and we can see our compressor runtime starting to increase again. So it's just a constant awareness. It's constant being on the floor with the gun and constant, fixing those air leaks. And then another real big one, not only does it apply to air leaks, but everything else. If you're not measuring it, you're not managing it. We're fortunate enough to have a good measuring system in one of our compressor rooms. The other 2 compressor rooms, we really don't know or have the data to prove that what we're doing is beneficial. We do from the other room, but the other 2 rooms, we don't have really enough information to make some good choices. So we're in the process this year, hopefully getting some more data loggers and some airflow meters to try to manage that process and collect more data to be able to find out if what we're doing is effective. So I think that was pretty much the last slide. I think we're pretty good on time, Maureen, as far as some questions. So I'll open it back up to you.
Sure. All right. Well, thank you. That was a great presentation. Obviously appreciate the little shout outs. We did not pay you to do that, so hopefully people realize that. Thank you. Thanks for that. So we did have quite a few questions come in, so let me just kind of plow through these here. The first one that had come in, you were talking about the Teflon tape and how you're trying to get people away from using that as a fixer. So someone was actually curious, what negative effect that actually had. So I don't know if maybe they're using that and they just haven't found the issues yet, but maybe you could speak to that a little bit.
I sure can. I think it depends on what you're using your compressed air for. We have a very high-tech process called mechatronics assembly. It does a lot of overmolding, a lot of inserting metal into plastic. We have just tons and tons of solenoid valves and cylinders. We started finding, when we started looking for leaks, we had these, I won't say the brand name because it's not their fault at all, but these banks of 8 solenoid valves put together. And the seals would be leaking. So when we would go in there and tear them apart, not only did we find some synthetic oil out of the compressors in there that were degrading the seal, we also found, bits of metal. We found Teflon tape. So all that stuff ends up somewhere. So if you get too much tape on the end of the fitting and it eventually ends up blowing off, it's going to go on down the line until it can't go anymore. So we found that Teflon tape actually stopping up solenoid valves and just getting places where we didn't want it to get. So after, like I say, pulling several hundred of these valves apart and working with some of the vendors, the recommendation was just to go to this Loctite type pipe dope. It's a little bit messier, but it seems to stay put and it seems to seal better also.
All right. Let's see. Next up. So is it possible to make changes after you find leaks to prevent leaks in the future? Have you all been able to do anything to try and, I know you mentioned the mowing the grass, that, you just never an end, but have you guys found any tips or tricks for at least trying to help keep some of them from coming back?
We have, like I say, we try to, we have all kinds of technical people out plumbing up stuff. I would say probably the awareness of how important it is to make sure you get the right fittings in place. Also, we find a whole lot of fittings that are basically just put on finger tight. So people kind of get in a hurry, they plumb up 2 or 3 things that they think's temporary, and then a month or 2 later they're permanent. They forgot they didn't put a wrench on it or didn't put any Loctite on it. So I would say the biggest thing is just awareness, making sure everybody understands how expensive compressed air is and how important it is to plumb something up right to start with rather than having to pull it apart and redo it.
Yeah. And you mentioned, kind of making sure everybody understands. So you had said how, once you guys had some success with this program, it, you guys had some recognition. You obviously had some budgetary kind of rewards, if you will. Anything else come out of that from kind of the corporate? Now they're not having to send their guy every year to go through and do the scans. Are they, looking to you all as kind of a model for what they want to do in their other facilities? What else has come from this that might be a good little case study for the other folks out there?
Yeah, we've had some other facilities. We have a facility down in Brazil. I think their electric cost is about 4 or 5 times what ours is. There's been some talk about maybe letting James and I go down there. That hasn't been finalized yet. But some of the successes that we've seen here and publicized, they're very interested in. As far as our facilities technician that used to come over, he's probably a little mad at us because we, I guess, in effect, put him out of the job. I mean, he's still with the company, and he's still doing a lot of work, but like I say, that old process of doing it once a year and then trying to get resources to go back and find and fix them just didn't work for us. So he's actually been very beneficial in helping work with us and train with us, and like I say, he's in and out of the plant every day, even though he's not directly part of our organization, but he still is a very good resource for us. And they're like us; they're short-handed. They've got plenty to do. So although we did, I guess, take a little bit of work away from them, they're really not too upset at us.
Yeah. Well, hopefully he's finding some more value-added tasks with that free time that he's got, so that all hopefully works out. Okay, so let's see. What kind of fittings do you guys use? Are there better brands than others that last longer, leak less, that you guys have noticed?
I don't notice that from brand to brand. We typically use a lot of SMC. We use a lot of Festo type fitting for our air tubes. We use a lot of brass. One of the things that we publish in our compressed air guidelines is we don't use any galvanized pipe. mainly because eventually moisture is going to get in those and it's going to rust, and the rust is going to get blown on down the system. So, the SMC and the Festo, that's just a couple of our vendors that we use because we use a lot of their stuff. And it seems to be fairly reliable and holds up good. The biggest issue we really see with fittings is people trying to marry up metric and standard, and in 90% of the cases, it just does not work out very well.
All right. And it looks like you've got a colleague on here because someone else with TE just typed in that your energy auditor recommended using both tape and pipe dope should be used. What are your thoughts on that?
I'm kind of curious who that is.
Oh, maybe I should hook you guys up after. Um,
Yeah.
okay.
What was the question again? I'm sorry.
Just saying that he wrote TE's energy auditor recommended using both tape and pipe dope should be used. What are your thoughts on that? I guess for fixing it, since you just said, not the tape, maybe.
Actually, back in our plating process where we do some nickel, gold, and tin plating, all of our compressed air lines back there are PVC. So we do use dope and Teflon together back there. It seems to work a little bit better out in the like say the main manufacturing area. We just tried anywhere where we're using compressed air to get away from the Teflon and just using the dope. The Loctite sealant that we use, we just almost never see any leaks. If it's put on properly and the fittings are the same and it's snugged up properly, we never see those leaks.
All right. And then someone was wondering if, knowing what you've learned now, would you order smaller CFM / HP compressors next time around?
That's actually one of the benefits of where we're at right now. In the main compressor room that I primarily talked about, like I said, we've got a 200 horse primary, a 200 horse trimming, and a 250 horse backup. One of those is near end of life. It's already been rebuilt 2 times. So we're actually considering for our trimming compressor getting maybe a 75 or 100 horse compressor. It will run less, use less energy, still be able to provide the redundancy that we have in the system. So we are actually considering that at this point.
All right.
There again, that's another big cost saving. So, a 75 or 100 horse is going to cost a whole lot less than a 200 horse, and it's going to be cheaper to maintain and cheaper to run.
All right, and last one here. We've got a few folks that have written in, but some of them are a little more UE specific, so we'll follow up with those folks after. But I promise, multiple people have asked this question, so it's not me just planting it. A couple folks were wondering if you could say again what ultrasound equipment it is that you've got that you guys have been using in this program.
We have three of the UE guns. We have the Cadillac version, the 15,000. And then we have 2 of the, I think, lower end models, the 3000. I would just recommend getting the UE to find out the differences in the benefits and the cost advantages of each. So we like them both, depending on the purpose. The 15,000 is, like I say, the Cadillac, and will do everything except fix the leaks for you. The smaller guns give you all the information. If you're just using the gun to fix air leaks, I would recommend the 3000. So.
Yep. All
but
right.
we did look at 2 or 3 other brands, but UE ultrasound guns seem to be very durable and have proven out to be very durable. And also the software that came with them, the spreadsheet that we use is very easy to use, and we really like that also.
Awesome. Well, we appreciate that. So yeah, if anybody has additional questions about that or about the software, like I said, we'll follow up with some of you guys offline to get those things answered. But David, thank you so much. I've just got a couple closing slides here, and then we'll let everybody get back to their day. But
Okay.
uesystems.com. We've got tons and tons of information up there, including that's where the recording of this webinar will be placed. Again, hopefully by tomorrow. So lots more information on leak detection. Software information as well, some webinars we've done specifically on that. For those of you that were looking for a little more info on how you actually pull those reports, hopefully anything that you guys are looking for you'll be able to find on there. So check that out, and of course get with us if something you're just not seeing what you need. We'd love for you all to stay connected with us. Our UltraProbe users group and Reliable Asset World users group on LinkedIn is a great place. Good forums where we almost don't even participate. It's pretty much folks like David and other customers typing in questions, looking for feedback and advice. So just a really good place to kind of take even some of these questions you guys had today and take those offline or kind of back online, but over to LinkedIn and kind of get some conversations going there. So a good way to connect with your peers who are also using and interested in ultrasound. You can also follow us on Twitter. We're constantly putting out different articles, not just ultrasound related, but pretty much anything and everything to do with reliability in general. So keep an eye there if you're into that kind of a thing. And one last plug here for our conferences, which are just right around the corner now. Our Ultrasound World and Reliable Asset World conferences taking place co-located May 10 through 13 in Clearwater Beach, Florida. Ultrasound World, if the presentation David just did is right up your alley and you're looking for stuff like that, that's basically what Ultrasound World is, but covering all the different applications. So it's just a great place if you're trying to build your program, start your program, whatever it is you're trying to do with ultrasound. Great opportunity. So if there's a chance for you to still find a way to make it there, we'd love to have you. Reliable Asset World, we kind of take the focus off of specifically ultrasound and take it to anything and everything reliability related. So you kind of can go down there and pop back and forth between the two sets of presentations, and hopefully it's a really good event for everybody that comes. So if you're interested, hit us up, let us know what we can do to help get you down there, and we'd love to see you. And for those that are on here that are coming, we're looking forward to seeing you down there in a couple weeks. So with that, I'll just leave this up here so you guys know how to get in touch with us. David, again, thank you so much. Thanks to everybody for joining us today. And we'll see you all back here hopefully on next month's webinar when we get that out there, okay? So everybody have a good rest of the day, and we'll talk to you all